Hello, future engineers, subscribers, viewers, and students. There is another video, sample problem video in dynamics, particularly kinetics of particles. I hope that through this video, you will improve your thinking skills, not only in dynamics, but also in all needed mathematics and thinking skills for you to be well prepared in your engineering respective courses. The motion of a particle is defined by the relation x equals 6t to the fourth minus 2t to cube minus 12t squared plus 3t plus 3, where x and t are expressed in meters and seconds respectively. Determine the time, the position, and the velocity when acceleration is 0. So let's begin with the position function. Then after this, we differentiate this twice to derive the expression for acceleration, and we equate it to 0 to determine the time where the acceleration is 0. So the velocity is dx dt, and it is equal to 24 t cubed minus 6t squared minus 24t plus 3. Then acceleration is, that's the expression for velocity. We also need this later after we solve for the time where acceleration is 0. Acceleration is the derivative of velocity with respect to time, and it is equal to 24 times 3, 72t squared minus 12t minus 24. Then we equate this to 0. Common factor is 12. So 72, acceleration is 72t squared minus 12t minus 24. So 12 quantity 6t squared minus t minus 2 equals 0. So let's factor this into 2t and 3t. So times, so 3t and 2t. So 3t we have times quantity minus 2, then 2t plus 1 equals 0, or you may use your calculator. Evaluate the time using your calculator and quadratic formula. So for this factor, t is negative 1/2, which cannot be because time should be positive. So t is 2/3, 3t minus 2 equals 0, so t is 2/3. So the acceleration is 0 when the time is 2/3. We then evaluate the position when t is 2/3. So x is 6 quantity 2/3 to the fourth minus 2 times quantity 2/3 cubed minus 12 times 2/3 square plus 3 times 2/3 plus 3. So the position of the particle when time is 2/3 is at 7/27, or approximately 0.2593 meter. Then for the velocity, we substitute t is 2/3 into this formula. So v equals 24 times t cubed minus 6t squared minus 24t plus 3. T is 2/3, so v is 24 times 2/3 cubed minus 6 times 2/3 quantity square minus 24 times 2/3 plus 3. So the velocity of the particle when acceleration is 0 is negative 77/9, or it is equal to negative 8.556 meters per second in decimal form. So that's it for this problem. So time, position, and velocity when acceleration is 0. We then proceed to problem 6, and problem 6 is this. The motion of a particle is defined by the relation x equals t cubed minus 9t squared plus 24t minus 8, where x and t are expressed in centimeters and seconds respectively. Determine A, when the velocity is 0, and letter B, the position and the total distance traveled when the acceleration is 0. So velocity again is the derivative of x with respect to time. So v is dx dt, and it is equal to 3t squared minus 18t plus 24. Then equating to 0, factor out 3. So v is 3 quantity t squared minus 6t plus 8. And the factors would be v equals, so 0 over 3 is 0, so t minus 2 and t minus 4 equals 0. So v equals quantity t minus 2 times t minus 4 equals 0. So the velocity is 0 when time is 2 seconds and when time is 4 seconds. Then the position and the total distance traveled when the acceleration is 0. So let's develop expression for acceleration. This is velocity. Acceleration is derivative of velocity with respect to time. And it is equal to 60 minus 18. And equate it to 0. So that means the acceleration is 0 when time is 18 over 6 or 3 seconds. So acceleration time is 3 seconds and the acceleration is 0 when the time is 3 seconds. We then compute the position x sub 3 when time is 3 seconds, going back to this expression here. So x3 is equal to 3 cubed minus 9 times 3 squared plus 24 times 3 minus 8. So x sub 3 is equal to 10.00 centimeters. Then for the total distance traveled, we need to compute the position of the particle when time is 0, when time is 1 second, when time is 2 seconds, and when time is 3 seconds, because time is 3 seconds when the acceleration is 0, so that we can trace the motion of the particle from 0 to 3. And from there, we can analyze the total distance traveled, which is the actual distance traced by the particle. So x sub 0 is obviously when time is 0, negative 8. Negative 8 cm, we just substitute in this position vector x is 0. The next position, rather. T is 1, so 1 cube is 1 minus 9 times 1 square, 1 minus 9, negative 8. Then minus 8 plus 24 times 1, so it is 8 centimeters when time is 1 second. When time is 2 seconds, we have 2 cube, which is 8, minus 8, 0, minus 9 times 2 squares, so negative 36, plus 24 times 2, 48, so 36, negative 36 plus 48 is 12. So x sub 2 is 12 cm, and x sub 3 is 10 cm from these calculations here. We then plot the motion of the particle for time 0, time is 1, time is 2, and time is 3. So these are the coordinates, position. So when time is 0, the particle was 8 centimeters to the left of the origin, and it moves to the right, so that when time is 1 second, it is now 8 centimeters to the right of the origin. This is time 0, time is 1, then time is 2, it is here at 12, then time is 3, it goes back to 10 cm position. So from 0 to 2, the motion of the particle is rightward, and from 2 to 3, it is leftward. So the total distance traveled by the particle is, of course, from negative 8 to 8, negative 8 to 0, that's 8. Then 0 to 12, that's 12. Then 12 to 10, that's 2. 12 minus 10 is 2. So again, negative 8 to 0, that's 8 cm. 0 to 12 plus 12, so 20. Then 12 to 10, 2. So that's why the total distance traveled is 22. So distance is 8 plus 12 plus 2. So I already explained that. I hope that you were able to follow. From negative 8 to 0, that's 8 distance traveled by the particle. 0 to 12, so from 0 to 12, that's 12. So plus 12, then 12 to 10, that's 2. So therefore, the distance traveled by the particle is 22 centimeters. So that's it for this problem. I hope that you were able to follow the explanations and the solutions.